Hi students, in this video we will study IPv datagram format. In the network layer, there are two different datagram formats. One is IPv4 and another is IPv6. I will explain each of the field in detail in the coming videos. VR stands for version, headline is header length, types of service TOS, length, and the entire row 16-bit identifier flags and fragment offset together makes fragmentation and reassembling. We will study fragmentation and reassembling in detail in the coming videos. And time to live TTL, the protocol name in the upper layer, header checksum, 32-bit source IP address, destination IP address, and options field which may contain the timestamp, record route taken, or to specify the list of routers to visit, etc. And the last field is the data field, which is a variable length data. Typically, a TCP or UDP segment will be the content of the datagram data part. We will see each of the fields in detail in the coming slides. Total, the 20 bytes of TCP header plus 20 bytes of IP header, that is 40 bytes of header length plus the application data will be the content of the datagram. VER version number. The first field is VER version number. It is a 4-bit field which specifies the version number of the IPv datagram. The two versions are there. One is IPv4 and IPv6. The datagram of the current version is IPv4 and the datagram for the new version is IPv6. By looking at the version number, the router can determine how to interpret the remaining part of the IP datagram. When the sender and receiver are in common agreement with the version number, then only they can exchange messages. And next field is header length. Because the IPv datagram can contain a variable number option in header field, that is, this is the options field which contains a variable length data. It may contain the timestamp of a datagram or the visited records, routers record, or future routers, the list of routers that may be visited. All these are the optional values specified in this options field. These together makes the length of the header vary. These 4 bits are needed. The header length 4 bits are needed to determine where the IP datagram's actual data begins. Actual data begin after the header is entered. So, the header length field, second field, which specifies the length of the header. A typical datagram is having 20 bytes of IP header. That is 20 bytes from the upper layer TCP layer plus 20 bytes of header in the current layer, network layer, and remaining part contains the datagram. So total of 40 bytes of header plus payload will be the data of the IPv datagram 4. The third field is TOS, types of service. Types of service determines the type of the IP datagram. For example, some datagrams are particularly require low delay. Some require high throughput. Some require high reliability. And various datagrams are distinguished from one another. The TOS is a 4-bit field and which can take various values depending on the nature of the datagram. The 4 bits can take different values like D, T, R, and C. D for minimum delay, T for maximizing the throughput, R for maximizing the reliability, and C for minimizing the cost. Depending on the nature of the datagram, these flag bits can be set as 1 or 0. Based on these values, the nature of the datagram is set. The nature can be of normal, minimum cost, maximum reliability, etc. And this table, you don't need to by heart all these things. Just remember 2-3 things and keep in mind the values related to DTRC determine the type of the service. The datagram length field is specifying the total length of the datagram. Total length include header length plus data length. Since the header length is varying, system identifies the starting point of the data from the total length field. Total length minus header field will take the starting point of the data storage. Or from that point onwards, the actual data is stored. Next three fields, identifier flags and fragmentation offset. These together make the fragmentation purpose. And we will study this fragmentation and reassembling in detail in coming videos. TTL, time to live. It stores a numeric value which specifies the life of the datagram in the network. This ensures that the datagram do not circulate forever in a network. This field is decremented by 1 in each time the datagram is processed by a router. When this TTL value becomes 0, the router will automatically delete the datagram from the network. The protocol field is used only when the IP datagram reaches its final destination. And the protocol number is the glue that binds the network and the transport layer together. But the port number we studied in previous classes, the port number is the glue that binds the transport layer and the application layer. This upper layer protocol means the data link layer provides this datagram to its upper layer to which of the protocol TCP or UDP. These are the protocols in the upper layer. To either TCP or UDP, the datagram will be delivered depending on the value stored in the upper layer. Header checksum. It is similar to the checksum in the transport layer. A header checksum is computed in the similar way as in the previous TCP itself. It is finding the ones complement value of the checksum, value of the datagram. In the in the TCP layer, the checksum computation was for the entire segment, that is for entire TCP or UDP segment, whereas in the datagram, the checksum is for the current datagram only. The purpose of the datagram is similar to the previous one itself, just to check the bit errors in the datagram. Source IP address and the destination IP address, which specify the datagram from where the datagram is coming and to where the datagram is going. Here the datagram is having IP address of 32-bit. IPV4 is using 32-bit IP address, whereas IP address at IPv6 is using 128-bit IP addresses. That is the key importance between IPv4 and IPv6. The options field allow the IP header to be extended with some additional values. As I said in the first slide, it stores different values and those values are optional. This field is omitted in IPv6. This field is making the IP datagram header variable length. And the last field datagram, last field of the datagram is data or payload, which contains the TCP header, TCP layer segment or UDP layer segment. That is the actual data to be sent. These are the various fields explanation in the IPv4.